Hello there, CP Algebra 1B. Welcome to another thrilling lesson, 11.3, picking up with square roots. And today, our essential question, how do you add and subtract them? All right, so add, subtract, square roots. It's all coming into play here. All right, so number one, we have 2 roots of 5 plus 2 roots of 5. All right, here is the main idea, everybody. If you have the same square root, so square root of 5 and the square root of 5, if you have the same square root, and only if, you can add them. So you can add like radicals, we call them. Okay? So 2 square roots of 5 plus 2 square roots of 5 is as easy as saying we have 4 square roots of 5. Think of it almost like a variable, like x. Okay, 2x plus 2x would be 4x. So 4 square roots of 5, that's your answer. That's it. Isn't that nice? Nice and easy? But wait, there's more. It gets a little more challenging. But that's the main idea. If they're the same radical, you can add them together. All right. Second example, 2 roots of 27 minus the root of 3. So right off the bat, you cannot add them together. The root of 27 and the root of 3 are different. But wait, there's more. If you can break down the square root, you should do that first. So the square root of 27, it's going to involve some of our work from before. So remember, we had perfect squares. We had 1 squared is 1, 2 squared is 4, 3 squared is 9, so forth. It's going to be helpful to know those. If we recall, we can think of this as, so that 2 is going to stay out front. That's this 2. The square root of 27, we'll think of it as the square root of 9 times the square root of 3. All right, and then minus the square root of 3. Magic that happens. The square root of 9 is just a regular 3. So I have this red 2 times the 3, and then I have a root of 3, and then minus a root of 3. All right, so we've made another square root of 3. We have 6 roots of 3. That's just 2 times 3. Minus a root of 3. At this point, they are the same square root. So we can subtract them, and it's just 6 roots of 3 minus 1 square root of 3. Final answer is 5 square roots of 3. So if you can break down a square root first, you need to do that and then see if you can add them together. Okay, so a little bit with that. After you break it up and then add them, there's really not too much else. But let's look at some other examples. Okay, 3 roots of 27 plus 3 roots of 12. Off the bat, let's just split them up, break them down first. We just did an example of 27. That's square root of 9 times square root of 3. Don't forget about this 3 out front. So the biggest thing is keeping track of like all the different types of numbers. Square root of 9 becomes this 3. A regular 3 out front means this is 9 roots of 3. Okay, plus 3, the root of 12, we'll think of it as the root of 4 times the root of 3. Well, the root of 4 is just 2 and times 3. So then we have 6 roots of 3. At this point, square roots are the same. So we have 9 plus 6, 15 roots of 3. If they were not the same, then you would just leave both square roots as your answer. But that's the case there. So lots of practice breaking down radicals and then adding them. Okay, let's look at a few more examples. Practice makes perfect. Okay, a negative inside here. So 54, let's think of the biggest perfect square that goes into 54. That's going to be square root of 9 times square root of 6. We have a negative out front. You could think of it as a negative 1. So this is really negative 3. Square root of 9 is 3. roots of 6 minus 2 roots of 6, negative 3 minus 2, negative 5 roots of 6. Nicely done if you followed along and got that one. Okay, so same old idea. 6, let's do 5 first. 18 and 18. So right off the bat, okay, since they're already the same square root, you could add them. Okay, and that means we have 6 roots of 18. You do want to break down the square root still, though, from there. So we'd have 6, 18 is really square root of 9 and 2. 6 square roots of 9 is 6 times 3 roots of 2, which means we have 18 roots of 2. So you could have added them together. You could also have broken them up first. So square root of 9 and 2 would have been 9 square roots of 2 plus another 9 square roots of 2. Either way gets us to the 18. So I know this is a little sloppy in here. Either way is fine. If you notice them right off the bat and you add them together, okay, 18 and 18 took us right to this step. Just the key thing, make sure you always break up square roots if possible. All right, 18 roots of 2, final answer. Moving on. 6. So pause if you'd like, and try. First step is breaking up the 18. Okay, so perfect squares that go into 18, 9 and 2. Okay. So this is 3 times 3, which is 9. We're adding 9 and 3, 12 roots of 2. Bada bing, bada boom. Okie dokie. Last examples, 3 roots. Oh, but notice they're all the same. So you can add them all together. 2 roots of 3, 3 roots of 3, minus 1 root of 3. Well, 2 plus 3 is 5, minus 1 is 4. 4 roots of 3. Boom, boom, boom. And our last example, negative 2 roots of 6 plus 3 roots of 6 minus root of 3. So here's an example where we have different square roots. These two are the same. They're buddies, square root of 6 and the square root of 6. This square root of 3, however, is not the same. So you just cannot, no matter how you change it, add it to the other two. So we're going to add together the orange ones. So negative 2 roots of 6 and 3 roots of 6 means we have just 1 root of 6. And the green part's all by itself, minus root of 3. 2 parts to your answer, but that is most simplified. All right, so key things: break down square roots, try and memorize those perfect square factors, and again, if they're the same radical, you can add them together. So try out those practice problems. The answers, I believe, will be posted or also shared with you as well. Do your best and have a great day, everybody.